All right. Hello, students. This is going to be an attempt of me explaining how to start the Punnet Square assignment that we're doing in class on Friday. I'm trying to hold the camera and write at the same time, so I apologize if it's a little jiggly. Number 1 on the instruction says, look at the picture, list the things you see in the space below, and identify what each item might represent. So if I look over here at the photo, I'm trying to point to now, I obviously see that we are looking at bees. I also see that there are letters represented in this diagram. There's E, capital E, and there are lowercase e's. If you remember from our monster baby assignment, the capital E is referring to a dominant trait, and the lowercase e's are referring to a recessive trait. I also notice that in my bees, they look similar, except their eyes are different. This bee has, I'm going to call it a black eye, and this bee has a white eye. And in the diagram, I see some black eyes and some white eyes. So I'd like you to take a second to write down some of those things that we just identified in this picture.
Okay, so you should have some information listed on your sheet now. Some of the things that we see are bees with black eyes and white eyes. We also see letters in the chart, and we remember that the capital letter refers to the dominant trait, and the lowercase letter refers to the recessive trait. Question number 3 says, what trait do you think might be represented in this picture? And we've already talked about that. We're obviously recognizing eye color as the trait that's represented in the picture. So now we're on to number 4, and we're asked to calculate the probability of each trait showing up from the information in the picture and answer the following questions. What we first need to understand is that as we're looking along the sides of this diagram, we are looking at the two parents. Let's just refer to the parent on the left-hand side as the mother and the parent along the top as the father. If these are the two parents, inside the diagram, we have represented their offspring. And the diagram has 4 boxes, which represents 4 different offspring. So if we come down to question number 4, 4A says, how many offspring with the dominant trait might show up? Well, which one is the dominant trait? We need to find our capital E. So if we come over to the mother, we see that she has a capital E and a lowercase e for her genotype. That's a term that we talked about on Wednesday and Thursday in class. So the E must be referring to the eye color. And the dominant eye color must be black because the mother has a dominant trait in her genotype. The father has 2 recessive traits, lowercase e's, and he has white eyes. So we must come to the conclusion that the offspring with the dominant trait are going to be the ones that have the capital E's. Therefore, 2 out of 4 of the offspring would have the dominant trait.
Question 4B asks, what is the ratio of colors? So now we need to think about, well, what colors are we talking about? We're referring to black and white eyes. So our ratio would be 2, it's very hard to write and hold the video camera at the same time, black, and then we draw a colon and we write 2 white. And we read this statement as 2 black to 2 white. And if we look up at the chart, it's clearly seen. 2 black-eyed offspring and 2 white-eyed offspring.
Question 4C asks, what percentage of offspring might have the dominant trait? Again, we're looking at black as the dominant eye color trait, and we have 2 out of 4, and if we calculate that into percents, that's half of the offspring, which would be 50%. Question 4D asks, how many offspring with the recessive trait might show up? So remember, our recessive trait is represented by the lowercase e, and the recessive trait only shows up if there are 2 of them in the genotype. So we have 2 recessive trait genes out of 4 for the offspring. And then the last question is, what percentage of offspring might have that trait, referring to the recessive trait? Again, it's 2 out of 4, or half of the offspring, which is 50%. That's a little warm-up to get you started with Punnet Squares.
So how do you complete a Punnet square that's not already filled out for you? Let's do this together on number 5. The scenario says, Tomas and Julie are about to have a child. Tomas has dark hair like his parents, represented with the genotype capital D, capital D. Julie also has dark hair, but her mother was blonde. Her genotype is capital D, lowercase d. How can we predict what color of hair their child might have? Work with your teacher to use a Punnet square to predict the characteristics of the child. As you can see, I filled in my Punnet square with the genotypes for the parents. Along the side, I have the mother's genotype, Julie's, capital D, lowercase d. Along the top, I have the father's, capital D, capital D. The next thing we're going to do is fill in the Punnet squares. For each square, you want to take the letter from the column of that square and the row of that square. So this first square will be represented with capital D, capital D. The second square will also be capital D, taking the capital D from the father and the capital D from the mother. This square, however, is going to be capital D, lowercase d, taking the father's dominant trait and the mother's recessive trait. And then finally, the last square is also going to be capital D, lowercase d. Notice that I always put the capital first. When you have a combination of dominant and recessive alleles, the dominant allele is written down first. Now I've completed my Punnet square. Let's see if we can figure out the answers to the questions using that information. Okay, so I've answered my questions 5A through E. 5A, how many capital D combinations are shown? I have 2. What color hair would these children have? They would have dark hair because the dark hair gene is dominant. How many capital D lowercase d combinations are shown? You would also have 2. What color hair would these children have? They would also have dark hair because they have the dominant dark hair gene, and it will win out over that recessive blonde hair gene if both are present. Question E says, is there any possible way that Tomas and Julie's children could have light-colored hair? Explain your answer. Well, I said no. They must inherit 2 recessive alleles for hair color to be blonde, and there is no combination of parent traits that would allow for that. We're going to continue using this new vocabulary over the next couple of weeks, and in the meantime, I would like you to practice the Punnet square problems on the following 2 pages. With the information I've given you, you should be able to try these out on your own and also answer the reflection questions on the back.